So in this video, ang i-discuss ko naman ay mga preparations, mga properties, and reactions of the so-called derivatives of water. So under this category, we have alcohols, which are alkyl hydroxides. So as an example, we have 2-propanol or the isopropanol. We also have ethers, which are alkyl groups connected through a single oxygen. Okay, we have an example here, diethyl ether, so 2 ethyl groups connected through this oxygen. We also have phenols, which are phenyl hydroxides. So may benzene ring, tapos may hydroxide na directly nakakonect sa benzene ring. And as an example, we have the para-methyl phenol. Okay, so this is a phenol, or you can also call this a para-hydroxy toluene. Pero since in-emphasize natin yung pagiging phenol niya, we call it the para-methyl phenol. Okay? So, under the derivatives of water, we have the alcohol. So, ang i-discuss ko muna sa video na to ay mga alcohols. Okay? So, recall lang natin na there are 3 types of alcohols. Primary, ibig sabihin yung iyong hydroxide group ay nakakonect sa isang primary carbon. So, as an example, we have 1-butanol. So, secondary alcohols, ibig sabihin yung iyong hydroxide group ay nakakonect sa secondary carbon. As an example, we have 2-butanol. So, for the tertiary alcohol, the hydroxide group is connected to a tertiary carbon. Okay, as an example, we have this 2-methyl 2-propanol or the tert-butyl alcohol. This is a tertiary butyl group. Okay, or we can also call this the tert-butanol. Okay, so now let's discuss the reactivity of alcohols. So since ang main functional group ng ating alcohol ay yung hydroxide group, okay, so i-discuss natin yung acidity ng hydrogen na to. So the acidity of this hydrogen depends on the stability of the alkoxide that will form. So ang nagdidictate or nag-govern ng stability na yon ay yung concept natin ng hyperconjugation. So recall natin, hyperconjugation is the ability of the neighboring carbons or the neighboring groups to share their negative charge density, okay, usually to stabilize the carbocation that will form. Pero it destabilizes carbanions. Kasi kung carbanion ka, hindi mo na kailangan ng additional charge density. Okay? So, adding more negative charge dun sa already negative charge will destabilize your intermediate or your alkoxide in this case. Okay? So, the more substituted alkoxide, therefore, are less stable. Okay? So, kapag mas substituted ang alkoxide mo, ibig sabihin kapag tertiary ang iyong alkoxide, more reactive siya or more basic siya. Okay? So, ibig sabihin, if the tertiary alkoxide is more basic, the tertiary alcohol is the least acidic, followed by the secondary, followed by the primary, and then the most acidic is the methanol. Okay? So, bases can react to alcohols to produce alkoxides. So, since very weak acids ang alcohols, kailangan natin ng very strong base para ma-abstract natin yung hydrogen ng alcohols dito. Okay? So, alkaline and alkaline earth metals are very strong bases pagdating sa ganitong klase ng process or reactions. And sodium amide, so yung amide, okay, is the conjugate base of ammonia. Ammonia is already basic, so this is far more basic than this particular ammonia. Okay, this is the conjugate base of ammonia. Okay, so NaH, the hydride, is also very basic. Grignard reagents, so yung mga alkylides, okay, they are very basic kasi they are negatively charged alkyl groups. Okay, so mataas ang basicity nila. They can abstract the hydrogen of the alcohol. So, for example, we have this. Okay, this is the propanol. Kapag nireact mo siya sa sodium amide, tapos NH3 yung ating solvent, pwede ka mag-produce ng this is 1-propanoxide. Okay, so pwede ring 1-propoxide. Okay, pwede rin nating i-name ng ganon. So, this is sodium propoxide or propanoxide. Okay, so here are some examples of your alkoxide preparation reactions. So, you can react, for example, ethanol with sodium amide in NH3 to produce the sodium ethoxide. So, magkakaroon tayo ng mga times na abbreviations lang yung makikita nyo. So, for example, the abbreviation for ethanol is ET, then OH. Okay? So, kapag na-abstract yung hydrogen yan, magiging NaOET. Okay? So, this OET is the ethoxide. Okay? So, nakadepende din yan doon sa name. So, kapag me, okay? For example, this is methanol, ET is ethanol. So, usually, ito yung mga ginagamit na abbreviation. So, mga propanols, mga butanols, usually, meron silang sariling abbreviation. So, for example, here, we have tert-butanol. So, this is HOT butanol. Okay? So, tert-butanol yung tawag dyan. So, kapag nireact mo siya sa sodium in diethyl ether, so, diethyl ether is 2 ethanols, or ethyl groups pala, connected through a single oxygen. Okay? So, that's diethyl ether. So, hinalo mo yung sodium sa diethyl ether, tapos nireact mo siya sa tert-butanol. So, ma-abstract yung hydrogen na to, magpo-produce tayo ng sodium, okay, O tert-butoxide. So, this is tert-butoxide. Okay? So, ganyan yung usual na abbreviation niya. So, for this one, this is isopropanol. Nireact mo siya sa sodium in diethyl ether. Nag-produce ka ng sodium isopropoxide. So, wala tayong usual na abbreviation dito. Okay? By the way, meron tayong mga abbreviations sa butanol, sa pentanol, etc. So, pwede nyo gamitin yung mga abbreviations na yan, lalo na kapag ilalagay nyo siya sa isang chemical reaction para hindi tayo nag-spend ng space. Kasi usually yung mga compounds, kapag sinusulat sila, malalaki yung space na kailangan. So, kapag sa arrow lang, for example, this one, so kung igagawin natin abbreviation niya, so ET, OH, so lalagyan natin ng Na, NH2, and NH3. So, magkakaroon na tayo ng NaOET. Okay, so pwede siyang isulat sa isang line. Okay, na hindi mo na kailangan i-drawing yung mga structures. Kung maliliit lang naman yung compounds. Okay? So, sa phenols naman, we can see that it doesn't need a very basic reagent. So, sodium bicarbonate is not very basic, pero it's basic enough to abstract this particular hydrogen here kasi yung ating phenoxide ay resonance stabilized. Okay? So, since resonance stabilized siya, acidic yung hydrogen na to. Okay? So for other preparation reactions of alcohols, we have number 1, the nucleophilic substitution of alkyl halides. So since may good living group ang ating alkyl halides, stronger nucleophiles like water can replace this particular good living group to produce the alcohol. Okay? So ang reactivity niya, SN1 ang mechanism kapag tertiary ang ating alkyl halide because of the stability of the resulting carbocation. So tertiary yung carbocation dyan. SN2 naman siya kapag primary ang ating alkyl halide. So kapag secondary, it's dependent on the environment as well. Kasi yung secondary carbon, it's quite stable. Okay, it can produce a carbocation, pero it can also undergo SN2 mechanisms. Depende dun sa situation. Okay, so this particular reaction is more efficient with heat. Kasi hindi naman ganun ka basic ang ating water to act as a base at high temperatures. So wala tayong competing elimination reactions. Okay, so for the next one, we have simple addition. So for the simple addition, we have the addition of H plus dun sa alkene. Okay? So mag-a-add ito dun sa less substituted carbon because of the Markovnikov rule. So according to the Markovnikov rule, again, okay, yung more substituted or the more substituted carbocation is the more stable carbocation. So the more substituted addition product is the more stable product. Okay? So siya yung magiging major product mo. Okay? So it also allows rearrangement kasi in the process or in the mechanism, nagpo-produce ka ng carbocation. So this particular carbocation can have some methyl or hydride shifts depende dun sa kung ano ang i-allow ng iyong mga conditions. Okay? So the stronger nucleophile or the nucleophile in this process will add to the more substituted carbocation after the production of the more stable carbocation. Okay? So, however, we have an addition reaction na hindi nagpe-permit ng rearrangement. Pero Markovnikov siya. So this is the oxymercuration, demercuration. So dalawang yung steps. So first we add mercuric sulfate in water and then we add sulfuric acid. This is an addition reaction pero it doesn't permit rearrangements. Okay? Markovnikov rule siya. Pero hindi siya nagpa-permit ng hydride or methyl shifts. Okay? So finally we have the hydroboration oxidation reaction. So this particular reaction is anti-Markovnikov. Okay? So ang ibig sabihin nun, yung ating OH group ay nasa less substituted na carbon after the reaction. Okay? So we can also prepare alcohols from carbonyl compounds and ethers. So sa carbonyl compounds, we can do reduction reactions or we can just add Grignard reagents. Okay? So para sa reduction reactions, we have the addition of sodium borohydride first. Tapos after nun, lalagyan natin siya sa acidic environment. So if you have an aldehyde, yung carbonyl carbon tsaka yung oxygen, magkakaroon sila ng tig-isang hydrogen. So kapag aldehyde ang iyong substrate, magkakaroon ka ng primary alcohol. Kapag ketone naman, secondary alcohol. So hindi naman tayo nagkakaroon ng carbonyl group na nagiging tertiary alcohol through reduction only kasi dalawa lang ang pwedeng ikabit mo dito sa ketone at isa lang ang pwede mong ikabit sa aldehyde. Okay? So ganun din ang nangyayari kapag nag-add ka ng lithium aluminum hydride. Okay? So same lang din yung process. You put first the reducing agent tapos maglalagay ka ng acid after. Okay? So again, aldehydes can produce primary alcohols. Ketones can produce secondary alcohols. Okay? So for the Grignard reactions, we can just add an alkylide, okay, through nucleophilic addition. Okay? So kapag ka nag-add yan, mapupunta dito yung pi bond, magiging lone pair siya ng inyong oxygen. Tapos, since magkakaroon ka ng ganitong intermediate, okay, this is an alkoxide, kailangan mo ng acid para malagyan mo siya ng hydrogen. So, therefore, makapag-produce ka ng alcohol. Okay? So, kapag ka aldehyde at naglagay ka ng Grignard reagent, nagiging secondary alcohol siya since this is an additional alkyl group. So, kapag ketones naman, magkakaroon ka ng tertiary alcohols due to the addition of another alkyl group. Okay? So, for the hydrolysis of ethers, kapag ka naman meron kang ether, nakadepende kung SN1 or SN2 yung mechanism. Kasi kapag SN1, okay, for example, we have this ether, susulat ko yung mechanism. Okay? Nag-add ka ng HBr. So, i-attack niya muna yung H. So, magpo-produce ka ng, of course, yung intermediate na merong hydrogen dito. So, plus yan. Okay? So, ang kukunin nito ay ito, yung bond between this carbon tsaka yung oxygen na to. Kasi this is the more stable carbocation compared dito. Kasi that's a primary carbocation kapag yun yung kinuha mo. Plus, OH. Okay? So, dito mag-a-add yung ating PR-. Okay? So, to produce the 2-bromopropane. Kaya ganito yung product dyan kapag SN1. Kapag SN2 naman, okay, since meron tayong polar aprotic solvent, mas magiging nucleophilic yun yung BR natin. So, add tayo ng HBr. So, CD5 muna, magkakaroon ka ng, so, mapupunta pala dito yung bond. Okay? So, H plus. Okay? So, yung BR mo, since very nucleophilic na siya, okay, mag-a-add siya dun sa less substituted na carbon, tapos kukunin nito yung bond. So, magkakaroon ka ng 2-propanol, tsaka ethyl bromide. Okay? So, kapag SN2, yung iyong nucleophile ay ma-attack dun sa more accessible carbon or sa less substituted carbon. Kasi this one is less accessible kasi marami siyang substituents. Okay? So, here are some other ways to prepare alcohols. So, for the first one, we have the reduction of acyl compounds. So, pag magre-reduce ka ng acyl compounds to convert them to alcohols, you can use either reducing agents or Grignard reagents. Okay? So, kapag reducing agents, you actually need 2 moles of the reducing agent per mole of the acyl compound. Bakit? The first hydride in your reducing agent will replace the chlorine. Okay? So, leaving group kasi yung Cl dyan. So, mapapalitan natin siya ng hydrogen. The second hydride will add to the carbonyl carbon para mag-produce tayo ng alkoxide. So, before the acidification, magkakaroon ka ng alkoxide. Tapos, yung chlorine, na-replace na siya ng hydrogen. So, after acidification, mapaproduce mo na yung alcohol. Okay? So, same lang din yung action kapag lithium aluminum hydride. Kailangan mo lang ng 2 moles of the hydride or the reducing agent per mole of the acyl compound para dalawa yung hydride na magamit mo. And to produce this particular product, okay, which is the important one, preparation of the alcohol. Okay? So, you can also add Grignard reagents. So, ganun din. 2 moles din ng Grignard reagent ang kakailanganin. The first alkylide will add to the compound to replace the Cl. So, yung pangalawang alkylide, it will add to the carbonyl carbon to produce the alkoxide, okay, intermediate before the acidification. So, ang mangyayari, dalawa yung R group na ma-add dun sa carbonyl carbon mo. So, if you add Grignard reagent sa inyong acyl chloride, magpo-produce ka ng tertiary alcohol. Okay? So, by the way, dito sa mga reducing agent, ang mapoproduce mo ay primary alcohol kasi hydrides ang ina-add mo dito. Dito, alkylides ang ina-add mo. So, nag-add ka ng substitution dun sa iyong acyl chloride. So, same lang din ang mangyayari kapag ketone. Although, kapag ketone, okay, let me correct this, isa lang ang kailangan mong R group or isa lang ang kailangan mong alkylide because one is enough. When hindi mo na mare-replace yung alkyl group na to. Okay, wala ka ng Cl or wala ka ng leaving group or wala ka ng good leaving group na i-replace. So, all you need to do is to add to this carbonyl carbon to produce the alkoxide. Tapos, after the acidification, mapoproduce mo yung tertiary alcohol. Okay? So, tertiary siya because of the addition of another alkyl group, okay, to produce a tertiary alkoxide. Tapos, after the acidification, tertiary alcohol na siya. Okay? So, next is the addition of formaldehyde to a Grignard reagent. So, ang mangyayari lang din dyan ay nucleophilic addition. So, after the addition of your Grignard reagent dun sa formaldehyde, okay, magkakaroon ka ng alkoxide. So, in this case, ang magiging intermediate product nyo dyan ay, okay, so isusulat ko lang yung reaction. So, MgBr plus, nandito yung iyong formaldehyde. So, nucleophilic addition to produce the alkoxide. Okay? So, nandito yung dalawang H ng iyong formaldehyde kanina. Okay? So, yung alkoxide na yan, i-treat mo lang ng acid para magkaroon ka ng primary alcohol. Okay? So, every time nag-add ka ng Grignard reagent sa formaldehyde, nagpo-produce ka ng primary alcohol. Pero kapag ka nag-add ka ng Grignard reagent sa ketone naman, in this case kasi ketone to, dalawa yung kanyang alkyl group, okay? Magpo-produce ka ng tertiary alcohol. Actually, diniscuss ko na to sa section natin sa carbonyl compounds. Okay? So, finally, we have the alcoholic fermentation. So, for the alcoholic fermentation, gagamit lang tayo ng yeast. Okay? So, the yeast contains enzymes that can convert your sugars to ethanol and CO2. Okay? So, yung baker's yeast na tinatawag or the Saccharomyces cerevisiae. So, meron siyang enzymes tapos kapag ka nireact mo siya dun sa sugar at the right conditions, magkakaroon ka ng ethanol and CO2. Okay? So these three reactions or preparation reactions are some ways to prepare alkadiols. So more specifically, ang tawag sa kanila ay vicinal diols kasi may dalawa tayong klase ng diols. So vicinal diol, ibig sabihin yung iyong OH groups, okay, ay nasa adjacent na carbons. So ganyan ang vicinal diol. Okay? So nandito yung iyong dalawang OH groups sa magkatabing carbon. Kapag naman geminal diol, ibig sabihin yung iyong dalawang OH group ay nasa iisang carbon or they are at the same carbon. Okay? So doon sila naka-attach sa carbon na yan. So dito, sa set natin ng reactions na to or mga preparation techniques natin, mga vicinal diols lang ang ipe-prepare natin. Okay? So first, we have the osmolation of alkenes. So if you add osmium tetroxide and a peroxy alcohol sa iyong alkene, mapoproduce tayo ng 1,2 diol or the vicinal diol. So this particular reaction is a free radical reaction, okay, with a free radical mechanism because of the presence of the peroxide. Okay? So yung mechanism niyan ay medyo mahaba. Meron tayong initiation step, propagation step, and termination step. Okay? So, we can also prepare alkadiols using the mild KMNO4 oxidation technique. So, ang gagawin nyo lang, mag-add lang kayo ng cold, dilute, and neutral KMNO4. So, this is a so-called Bayer's test or Bayer's reagent. This is actually a test to determine if your compound is an alkene or not. Okay? Kasi kapag hindi siya alkene, negative siya sa Bayer's test. Kapag nag-produce siya ng MnO2, okay, na solid, which is the brown precipitate, ibig sabihin meron tayong presence ng alkene. Kasi yung alkene natin naging alkadiol. Okay? So, ganyan yung test natin sa alkenes. So, finally, we have the epoxide ring opening. So, this particular reaction is an addition reaction. Okay? So, mangyayari, mag-a-add lang muna yung H plus dun sa iyong oxygen. Tapos, kukunin ng oxygen yung carbon-oxygen bond para mag-leave siya ng carbocation. And then, the nucleophile will add to that carbocation to produce the diol. Okay? So, this particular reaction or addition reaction has a Markovnikov mechanism or follows the Markovnikov rule. Okay? So, for this set of problems, ang gagawin natin, ipe-prepare natin yung mga alcohols from their respective precursors. Okay? So, for number 1, we will prepare 1 butanol from butane. Okay? So, paano natin gagawin yon? We'll subject butane through a series of reactions hanggang magawa natin yung 1 butanol. Okay? So, ang unang gagawin natin ay free radical substitution. Okay? So, lalagyan natin siya ng bromine with light in CCl4 or any organic solvents na non-polar para magawa natin yung alkyl halide. So, ang product nito ay 2-bromo-butane. So, after nyan, gagawa tayo ng alkene na non-Zaitsev. So, paano natin gagawin yun? Sa-subject natin tong alkyl halide sa reaction wherein we will introduce hindered base. Okay? So, ang hindered base na alam natin ay yung sodium tert butoxide. Okay? So, the tert butoxide is a hindered base. So, magkakaroon tayo ng non-Zaitsev alkene. So, ang solvent nito ay tert butanol. So, we will also subject the reaction through heat para magkaroon tayo ng mas efficient na elimination reaction. Okay? So, magkakaroon tayo ng 1-butene. So, after ng elimination, gagawa naman tayo ng non-Markovnikov na alcohol. So to be able to do that, we will subject this alkene through the hydroboration oxidation reaction. So sa hydroboration oxidation, first lalagyan natin siya ng BH3 in THF, tapos lalagyan natin siya ng sodium hydroxide or any salt na may hydroxide, tapos hydrogen peroxide. Okay? So makakagawa tayo ng 1-butanol. Okay? So that's a non-Markovnikov alcohol kasi non-Markovnikov ang addition reaction na to. So next, we will prepare this compound from methyl cyclopentane. So paano natin gagawin yan? Halos pareho lang nung ginawa natin sa number 1. So una, yung methyl cyclopentane, lalagyan muna natin siya ng bromine. Okay? Tapos organic solvent, okay? Para magkaroon tayo ng alkyl halide. So we need to functionalize this alkane. Okay? So after nyan, non-Zaitsev elimination din. So sodium tert butoxide sa tert butanol. Okay? So after nyan, meron tayong alkene na product. So hindi dito mapupunta yung ating double bond because the reaction is a non-Zaitsev formation or addition. Okay? So yung ma-form nating alkene dyan ay non-Zaitsev. So next, again, kailangan natin ng non-Markovnikov alcohol kasi kung Markovnikov ang alcohol natin, mapupunta siya dito sa carbon na to. So kailangan natin ng non-Markovnikov na reagent. So we'll just use the hydroboration oxidation reagents. So BH3, BHF, and then hydroxide with hydrogen peroxide. So makakapag-produce tayo ng non-Markovnikov na alcohol. Okay? So that's for number 2. So for number 3, mapaproduce naman tayo ng meta-methyl phenol from benzene. So paano tayo makakapag-produce ng meta-substituted na benzene? So ang gagawin muna natin, lalagyan muna natin si benzene ng meta-directing na substituent. So si benzene, lalagyan natin muna ng nitro group. Kasi we can produce phenol from the Sandmeyer reactions. So yung Sandmeyer reactions, ang kailangan niya ay diazo na compound. So yung diazo na compound, you can produce that from nitro substituted benzene. Okay? So HNO3, H2, SO4 muna. So lalagyan natin siya ng nitro group. Okay? Since the nitro group is meta directing, yung Friedel-Crafts alkylation natin, okay, ay magkakaroon ng result na meta na methyl nitrobenzene. Okay? So now we will perform the diazotization. So kapag diazotization, i-reduce muna natin si NO2 by Clemmensen reduction. So FeHCl. So magkakaroon tayo ng aniline dyan. And then, lalagyan natin siya ng nitrous acid, okay, with sometimes with sodium nitrite para mas maraming nitro groups. Okay? So after nun, kakaroon tayo ng diazo compound. So after nyan, lalagyan natin ng water. Okay? So yung water, magsa-substitute siya dun sa diazo or dun sa azide na ma-form para magkaroon tayo ng phenol. Okay? So magiging OH na yung ating NO2 dun sa reaction. At meta-substituted yung magiging product. Okay? So for number 4, gagawa tayo ng obviously this is a non-Markovnikov alcohol. Tapos meron tayong methyl cyclohexane, tapos meron tayong formaldehyde. So pwede nating gawing Grignard reagent muna ito, okay? Tapos mag-a-add na lang siya dun sa ating formaldehyde. So paano natin gagawin yun? Yung ating methyl cyclohexane, re-react natin sa bromine with light, okay? Tapos organic compound. So magkakaroon tayo ng tertiary alkyl halide. Tapos non-Zaitsev na elimination. So sodium tert butoxide with tert butanol, tapos heat. Okay? So after nyan, magkakaroon tayo ng non-Zaitsev na alkene. So pwede natin tong lagyan ng bromine, pero ang gagawin natin ay non-Markovnikov. So HBr, tapos meron tayong peroxide. So the peroxide effect will provide or will result to the formation of the non-Markovnikov na alkyl halide. Okay? So, pwede natin tong lagyan ng Grignard reagent. So, lagyan muna natin ng Mg tas ether. Okay? So, magkakaroon tayo ng Grignard reagent. Okay? So this Grignard reagent will be will be reacted with this formaldehyde. So iurong ko lang tong number 5 para magkaroon tayo ng space. So isusulat ko lang dito ulit yung Grignard reagent natin. Okay. So ilalagay na natin dito yung ating formaldehyde. Okay. Tapos magkakaroon tayo ng alkoxide because the Grignard reagent will add to the formaldehyde through the nucleophilic addition. Okay, so magkakaroon na tayo ng so this is the oxygen here. Okay, ganyan. So, kung meron na tayong alkoxide, i-react na lang natin siya sa H+ or any acid environment para magkaroon tayo ng alcohol. Okay? So, ganyan yung synthesis ng alcohol na to from this and the formaldehyde. Okay? So, finally, for number 5, kailangan daw nating mag-produce ng 1-propanol and the isopropanol from this compound. Okay? So, meron tayo ditong cleavage reaction na gagawin. Okay? So, paano natin i-produce? Okay? So, add muna tayo ng Br with CCl4. Okay? So, magkakaroon tayo ng tertiary na alkyl halide. Tapos, i-subject natin sa Zaitsev elimination. So, pwede natin gamitin yung sodium hydroxide with heat, okay, para magkaroon tayo ng Zaitsev na alkene. Tapos, pwede nating i-cleave yung alkene na to through, okay, so isulat ko lang sa next line. So, i-cleave natin through ozonolysis, O3, to zinc with heat, or H+, para mag-produce tayo ng carbonyl compounds, okay? Okay. So, ang mapoproduce natin ay yung aldehyde and ketone kasi magki-cleave yung ating double bond. Tapos, i-reduce lang natin yung mga carbonyl compounds using the reducing agent. So, pili lang kayo kung lithium aluminum hydride or sodium borohydride. So, gagamitin ko na lang yung lithium aluminum hydride. Okay? Tapos, syempre, mapoproduce kasi tayo dyan ng alkoxide. So, kailangan natin ng acid environment. Okay? So, magpoproduce na tayo ng isopropanol tsaka 1-propanol. Okay? So, this is for this particular problem set. So, let's proceed to the reactions of alcohols. So, paano naman natin nako-convert yung alcohols into other functional groups? Okay? So, for the first one, we have nucleophilic substitution using concentrated halo acid para ma-convert natin yung alcohols to alkyl halides. So, ano nangyayari dito? So, for the mechanism, okay, ang nangyayari ay nag-a-add yung ating H+, since yung ating halo acids ay usually strong, kasi HF lang naman yung weak acid, usually ang ginagamit mo rito ay HCl or HBr. So, nag-a-add yung ating H+ dun sa alcohol, magkakaroon ka ng intermediate. Okay? So, yung iyong chloride or bromide, nagsasubstitute siya dun sa iyong alkyl group. Okay? So, SN1 siya kapag tertiary ang iyong alcohol because mas stable ang iyong tertiary carbocation. Pero kapag primary ang iyong alcohol, the substitution will be most likely SN2. Okay? Tulad na nangyayari dito. Kasi hindi ganun ka-stable ang primary carbocation. So, simultaneous na lang yung ginawa kong mechanism. Okay? So, nag-produce siya ng alkyl halide. So, this is one way to produce alkyl halides from alcohols. So, nucleophilic substitution using a very concentrated acid. Bakit concentrated? Para ma-push yung equilibrium forward. So, as you add more reagents, nagkakaroon ka ng production ng alkyl halide due to the Le Chatelier's principle. Okay? So, for the next one, we have acid catalyzed elimination. So, gagamit ka naman ng ibang acid, okay? So, yung gagamitin mong acid, dapat yung kanyang conjugate base ay very weak nucleophile. So, ang example nun ay H2SO4. Okay? So, kapag H2SO4 kasi, yung kanyang conjugate base ay yung bisulfate. So, the bisulfate is a very weak base kasi very strong acid si H2SO4. So, ibig sabihin, hindi siya mag-a-act as a nucleophile kahit concentrated pa siya. Okay? So, for the mechanism, imbis na magkaroon ka ng substitution reaction, elimination lang siya. So, again, we have this alcohol, no, re-react natin siya sa H+, since hindi naman natin kailangan nung ating conjugate base. Okay? So, ang mangyayari, magkakaroon ka ng ganitong intermediate. Okay? So, imbes na mag-substitute si bisulfate, since hindi siya ganun kalakas or hindi siya ganun ka-strong na nucleophile, yung iyong adjacent na hydrogen or yung hydrogen na katabi ng carbon na ito, okay, yung carbon-hydrogen bond na to, madodonate na lang siya doon sa bond para mag-produce ng alkene. So, kapag na-donate siya doon, pwede na umalis yung water. So, this is positively charged kasi. So, kukunin niya yung bond na yan. So, magpo-produce ka ng alkene tsaka water. Again, this requires a very concentrated acid kasi this could go back to the reagents and pwede siyang bumalik doon sa inyong reactants. Okay? Ma-reconvert siya back to the initial state. Kasi water is a stronger nucleophile. So, baka ma-add siya. Okay? So, kailangan concentrated yung iyong acid para ma-push yung equilibrium forward. Okay? Ma-push siya forward. Okay? So, the elimination reaction is E1 po for tertiary alcohols. E2 naman siya kapag primary alcohols. Again, this is due to the stability of your carbocation. Okay? So, we then have the catalytic substitution. So, this is the easier way to produce your alkyl halides from alcohols. So, kailangan mo lang ng catalyst. So, yung PCl3 or PBr3, magpo-produce siya ng alkyl chloride and alkyl bromide respectively. Okay? So, this reaction is usually SN2. So, primary and secondary alcohols are more reactive towards this particular reaction kaysa sa mga tertiary. Kasi yung mga tertiary alcohols, usually kailangan nila ng environment or yung solvent effects na magre-require na mag-attack yung iyong mga reagents more strongly. So, kailangan nila ng stronger nucleophile kapag tertiary. Okay? Kasi mas mahirap i-access ang mga tertiary alcohols because of the substitution of the tertiary carbon. Okay? So, next we have the Williamson ether synthesis. So, usually, sa Williamson ether synthesis, kino-convert nyo muna yung alcohol into an alkoxide. So, usually, ang gagawin mo rito, lalagyan mo siya ng sodium para magkaroon ka ng sodium propoxide or propanoxide. Okay? So, yung alkoxide, okay, magsa-substitute siya dun sa iyong alkyl halide through SN2. Okay? So, syempre, kapag SN2 ang mechanism, favored siya for primary and secondary alkyl halides. Okay? So, these are the reactions for alcohols. Mainly conversion lang to ng alcohols to alkyl halides. And, syempre, meron tayo doon sa alkenes. Okay? So, now let's proceed to the oxidation of alcohols. So, bago natin to i-discuss in detail, tingnan muna natin yung mga iba't ibang types ng alcohol. So, example, we have the primary alcohol. Okay? So, this is 1-propanol. Meron siyang dalawang exchangeable na hydrogen dun sa inyong carbon na directly nakakabit dun sa hydroxide. So, next, meron tayong secondary alcohol. Okay? So, meron siyang isang exchangeable hydrogen na nakakabit dun sa carbon na directly nakakabit dun sa iyong hydroxide. So, yung tertiary alcohols, wala siyang gano'n. Wala siyang exchangeable hydrogens. Okay? Kasi tertiary alcohol siya. Yung tatlong substituents ay puro carbons yun, tapos yung isa ay hydroxide. Okay? So, tertiary alcohols are non-oxidizable. Okay? Hindi mo siya na-oxidize using yung KMnO4 or yung chromium trioxide. Okay? Ang na-oxidize lang natin usually ay yung secondary at yung primary alcohols. Siyempre, magkaiba sila ng behavior towards your oxidation. Okay? So, magkaiba sila ng products depende sa ginamit mong oxidizing agent. So, kapag primary alcohol, they have two exchangeable hydrogens. So, kapag nireact mo yung primary alcohol sa chromium trioxide or other oxidizing agents with acid, okay, pwede rin KMnO4 na hot and acidic, magpo-produce ka ng carboxylic acid. So, ang nangyayari dyan, yung oxidation process mo from primary alcohol nagiging aldehyde, tapos from aldehyde nagiging carboxylic acid. Kasi aldehydes are also oxidizable compounds. Okay? So, yung carbonyl compound na yan, oxidizable yan. Na-oxidize pa siya further ng iyong chromium trioxide or KMnO4. Okay? So, for secondary alcohols, meron siyang isang exchangeable hydrogen. So, from your 2-propanol or isopropanol, pag inoxidize mo siya using the chromium trioxide, nagiging ketone siya. And ketones cannot be further oxidized. Okay? Hindi na siya na-oxidize further ng chromium trioxide para mag-produce ng carboxylic acid like the primary alcohol. Okay? So, no reaction na siya. So, tumitigil na yung reaction sa pag-produce natin ng ketone. So again, if you have a primary alcohol at nireact mo siya sa oxidizing agents, KMNO4 or chromium trioxide, nagiging carboxylic acid siya. Kapag naman secondary, yung alcohol mo, nagiging ketone siya. Okay? So for tertiary alcohol, since wala siyang exchangeable hydrogens and it is non-oxidizable, tulad ng sinabi ko kanina, wala siyang reaction sa mga oxidizing agents na nandito. So KMNO4 or chromium trioxide. So here we have the summary of the oxidation reactions for alcohols. So meron tayong primary alcohol, kapag nireact natin sa chromium trioxide or KMNO4, magpo-produce siya ng carboxylic acid. Kapag naman secondary alcohols, nireact mo sa same oxidizing agents, magpo-produce ka ng ketones. So kapag naman nireact mo siya sa pyridinium chlorochromate, so PCC is pyridinium chlorochromate. So this particular oxidizing agent is a mild oxidizing agent. So ang nangyayari dyan, imbes na dumediretso siya sa carboxylic acid, yung primary alcohol mo nagiging aldehyde lang. Okay? Yung aldehyde hindi na siya further na co-convert sa carboxylic acid ng inyong PCC. So kung gusto mo mag-produce ng aldehyde from primary alcohols, PCC lang yung gagamitin mo. Pero kung gusto mo siyang i-convert totally to carboxylic acid, gumamit ka ng either chromium trioxide or KMNO4 with H+, of course. Okay? So, kapag naman secondary alcohol, pareho lang din ang nagiging result. Kapag nireact mo siya sa PCC, nagiging ketones lang siya tulad ng reaction niya sa chromium trioxide or sa KMNO4. So, we have another reaction. Ang tawag dito ay nitration of alcohols. So, anong ibig sabihin nun? Yung iyong alcohol, nako-convert lang siya sa nitrated na alkane or nitroalkane. Okay? So, yung H na to, nagiging NO2 lang kapag ka nilagyan mo siya ng concentrated nitric acid. So, kapag mas maraming hydroxide groups ang yung compound, lahat yon nako-convert lang to nitro. Okay? So, for example, this one, yung H nito naging nitro. So, yung tatlong hydrogens dito naging tatlong NO2 din. Okay? So, the same happens sa secondary and tertiary as long as meron kang alkyl hydroxide, nagiging nitrate. Okay? So, ganun din ang nangyari dito sa product na to. So, yung dalawang hydrogen na to naging dalawang nitrate. Okay? So, all you need to do is to add concentrated nitric acid. So, these particular compounds are explosive compounds because of the bond. Okay? So, yung bond ng oxygen and nitro group, medyo weak yung bond na yan. So, their energy kapag na-break yung bond na yan is exothermic. So, nagkakos sila usually ng explosions. So, usually yung inyong mga nitro alkanes, they are explosives. Okay? So, here we have a table illustrating the different reagents or test reagents that can discriminate between primary, secondary, and tertiary alcohols and even your phenols. Okay? So, unahin muna natin yung PCC. Siyempre, kapag primary alcohols, nagpaproduce siya ng aldehydes. So, you can test for aldehydes after that. Kapag naman secondary alcohols, nagpaproduce siya ng ketones. Actually, another test that can distinguish between aldehydes and ketones is called the Tollens test. So, i-discuss ko to sa carbonyl compounds. So, if you have a primary or secondary alcohol, you can do subsequent tests. So, unahin mo muna yung PCC, and then after the PCC, you'll test it using the Tollens test para malaman mo kung ketone siya or aldehyde. So, positive ang Tollens test sa aldehyde, negative siya sa ketone. So, pwede mo na ma-distinguish ngayon yung mga alcohols mo. Okay? Siyempre, PCC is negative pagdating sa tertiary alcohols kasi tertiary alcohols are non-oxidizable alcohols. And wala rin siyang reaction sa inyong mga phenols. Okay? So, the next reagent is called the Lucas reagent. So, this is ZnCl2 in HCl. So, this particular reaction is SN1. So, pinakamabilis ang Lucas test or pinakamabilis ma-convert sa alkyl chloride ang mga tertiary alcohols because the tertiary carbocation is the most stable. Okay? So, if you have a tertiary alcohol, pinakamabilis yung formation niya ng alkyl chloride. Very slow siya sa secondary at saka sa primary alcohol. And wala siyang reaction sa mga phenols. So, to be able to test if the alcohol is primary, secondary, or tertiary, pwede mo siyang isubject sa Lucas test. Kung mabilis yung reaction time ng Lucas test, most probably it's a tertiary alcohol. Mahirap i-distinguish ang secondary and primary alcohol sa Lucas test because they are both happening at a very slow pace. Medyo mahirap ang substitution ng secondary and primary compared sa tertiary. Okay? Kasi comparable ang stability ng secondary at primary alcohols. So, meron din tayo ditong Jones reagent. The Jones reagent is the chromate with acid. Okay? This is chromic acid usually. So, Pwede rin natin gamitin yung hot acidic KMnO4. Okay? So, kapag ka sa primary alcohols, nagpo-produce siya ng carboxylic acid. So, kapag ka nag-produce siya ng carboxylic acid, you can test the pH. So, kapag acidic, ibig sabihin, nag-produce siya ng carboxylic acid, the alcohol is then primary. Kapag naman secondary, ketones, so walang na-produce na acid, so the pH will not change. So, no reaction din siya sa tertiary alcohols. So, ibig sabihin, this Jones reagent can distinguish primary alcohols from other alcohols. However, pwede mo ring i-test yung ketones afterwards. Okay? So, a test for carbonyl compounds in general is called the 2,4-DNP test. Okay? So, lalagyan mo lang siya ng 2,4-dinitrophenylhydrazine. So, this particular reagent is positive for aldehydes and ketones. So, kung meron kang primary alcohol or secondary alcohol na kino-compare, pwede mo i-test yung acidity. Pero kung ang kino-compare mo ay secondary and tertiary alcohol, tapos sinubject mo siya sa Jones reagent, you can test the product by adding 2,4-DNP. Pag negative siya sa 2,4-DNP test, ibig sabihin tertiary siya. Kapag positive, ibig sabihin naging ketone yung alcohol. Ibig sabihin siya ay secondary. Okay? So, for phenols, nagiging quinones ang iyong phenols kapag tinest mo siya using the Jones reagent. So, meron din tayong separate test for quinones. Okay? So, pwede kang mag-distinguish if your alcohol is primary, secondary, tertiary, or a phenol kung gagamitin nyo yung Jones reagent. Basta dapat meron kayong second test. Okay? For sodium bicarbonate, since all alcohols, primary, secondary, and tertiary alcohols are more basic than sodium bicarbonate, hindi sila nagre-react sa sodium bicarbonate. Ang nagre-react lang dyan ay yung phenols because the phenol is more acidic than sodium bicarbonate. So, siya lang yung nagpa-positive ang result. So, kapag nag-positive siya sa sodium bicarbonate test, ibig sabihin, that reagent is a phenol. Okay? Finally, we have the ferric chloride reagent. Ferric chloride reagent is a complexing reagent na nagpo-produce ng color. Okay? So, since your phenols have this particular pi system, since meron siyang aromatic group, siya lang yung usually nagpo-produce ng colored result. Alcohols do not have this particular pi system, usually, so hindi sila nagpo-produce ng colored complex. Okay? So, here we have another set of problems. Ang gagawin lang natin, ipipredict lang natin yung products for each reaction step. Okay? So, for number 1, we have this 2-butanol na may specific stereochemistry yung kanyang hydroxide. Okay? So, that's towards the observer because of the wedge. So, ang gagawin natin, i-react daw natin siya with the tosyl chloride and then water. So, ano nangyayari dyan? So, yung ating alcohol, okay, kapag nireact daw natin sa tosyl chloride, magiging tosylate. Okay? So, this tosylate then reacts with water through an SN2 mechanism. So, this is a substitution reaction. So, since SN2 siya, magkakaroon tayo ng change dun sa stereochemistry. Magkakaroon ng reversal dun sa stereochemistry. So, magkakaroon tayo ng alcohol pa din, pero away from the observer na siya. Okay? Kasi, this water, okay, substitutes to the tosylate para magkaroon ka rin ng alcohol. Okay? So, magiging product ng reaction for the first step is an alcohol or the same 2-butanol pero reverse na yung stereochemistry ng hydroxide. Okay? So next, we have the reaction of this alcohol with NaNH2. So NaNH2 is sodium amide. So this particular reagent is very basic. So ang gagawin niya, i-abstract niya yung hydrogen para mag-produce tayo ng alkoxide. So yung alkoxide, magre-react naman siya dun sa ating propyl bromide to produce an ether through the Williamson ether synthesis. Okay? So mangyayari, same pa rin yung stereochemistry. Okay? Pero this time, propyl group na yun nandito. Because the alkoxide, okay, kung magiging alkoxide man to, it will substitute to this carbon. Tapos aalis yung ating bromide. Okay? So that's for number 1. So for the second one, yung ating cyclopropane or cyclopentane, ire-react natin sa bromine with light, okay, para magkaroon tayo ng bromocyclopentane. Okay? So after nyan, ire-react daw natin siya sa hydroxide with heat. So this is an elimination reaction. So matatanggal yung ating Br, magiging alkene. Okay? So yung alkene daw, after nun, yung ozonolysis natin. So react natin siya sa ozone and then zinc with H+. So ang mangyayari lang dyan, mag-cleave yung double bond. So magkakaroon ka ng dialdehyde. Okay? So yung dialdehyde na yan, ire-react daw natin sa lithium aluminum hydride and then H+. So this is a reduction reaction. So yung carbonyl groups magiging OH groups. Okay? So ito yung ating product for number 2. Okay? So next, we have number 3. So ang unang reaction ay Friedel-Crafts alkylation ng ethyl group. This ethyl group will be the one to add to the benzene. So magkakaroon tayo ng ethyl benzene. Okay? And then, i-react daw natin yung ethyl benzene sa bromine with light. Okay? Bromine with light muna. So magkakaroon tayo ng ganitong compound. Okay? Pero after nun, i-add natin yung magnesium with ether or magnesium in ether. So magiging MgBr yung ating product. So after nyan, i-react daw natin itong Grignard reagent na to sa acetaldehyde or sa ethanol. Okay? So kapag nireact mo kasi ang carbonyl compound sa Grignard reagent, this is a nucleophilic substitution. Okay? Or nucleophilic addition pala. I mean. So kapag nucleophilic addition, you will produce an alkoxide. Okay? So dito nag-add, okay, nagkaroon ka ng alkoxide. So nandito yung methyl group. This is the ethanol. Okay? So nandito yung isa niyang hydrogen. Pero hindi ko na ilalagay. Okay? So, ganyan yung mapoproduce niyang alkoxide. Pero since nalagyan mo siya ng H3O+, magiging alcohol siya. Okay? So, that's the product for number 3. So, for number 4, we have this methyl cyclohexane. So, ang una daw natin gagawin, mag-add tayo ng Br2 with light. So, this is just a free radical bromination reaction. Okay? So, magkakaroon tayo ng ganitong product. So, syempre yung ating Br ay mag-a-attach dun sa most substituted na carbon. Okay? So, after ng bromination, meron tayong elimination. But the elimination is anti-Zaitsev or non-Zaitsev. Okay? Because of the hindered base. So, ang gagawin natin, okay, magpaproduce tayo ng alkene na hindi Zaitsev. Okay? So, hindi pwedeng mapunta dito yung double bond because that's a Zaitsev alkene. Since the base is hindered, dapat non-Zaitsev siya. Okay? So, then, we perform an hydroboration oxidation reaction. So, magpaproduce tayo ng non-Markovnikov na alcohol naman. Okay? So, this is the non-Markovnikov na alcohol. Okay? So, after nyan, i-react daw natin yung alcohol sa PCC. Okay? And then, sa Grignard reagent, which is the CH3-MgBr. So, kapag nireact natin sa PCC yung alcohol, magiging aldehyde. Okay? Pero since mag-a-add din tayo ng Grignard reagent, okay, magkakaroon tayo ng alkoxide. Okay? So, since hindi naman indicate dito na lalagyan natin siya ng H3O+ para maging alcohol, the product will be an alkoxide. Okay? So, usually lalagyan natin siya na OMgBr for the charge balance. Okay? Kasi ang Mg ay 2+, ang Br ay minus, so the alkoxide is minus, so magkakaroon tayo ng parang salt. Okay? So, usually nilalagay nila to ng parang ganito, OMgBr. Okay? Para salt form. Okay? So then, we have number 5. So sa number 5, nilagyan muna natin siya ng cold dilute neutral KMNO4. So this is one way to produce Alkadiols or the vicinal diols. Okay? So this is the Bayer's reagent nga pala. So magkakaroon ka lang ng vicinal diols. So after mong i-subject yung alkene sa Bayer's reagent, lalagyan mo naman siya ng hot acidic KMNO4. So this is more or a stronger oxidation. So yung alcohols magiging ketones. Okay? So this is our discussion on the nature, preparation, and reactions of alcohols. So sa susunod na video, i-discuss ko naman yung nature, preparation, and reactions of ethers and epoxides. Okay? So see you next video.